Chapter 7 Boundary Condition. Thus far, it has basically been discussed how waveforms of one energy density level pass into a higher one, eventually causing the center of a system to increase in energy density and symmetry. The mechanics of this phasing shall now be examined in even greater detail. In a perfect ideal field, the energy density gradient is so perfect that individual energy density levels would be infinitely thin and therefore indistinguishable. However, in the real world, density levels are often easily distinguishable, such as where the ocean and the sky meet. This meeting place of two different energy density levels is the place where their two waveforms meet and begin to phase unify to varying degrees, and thus it does not behave like one level or the other. It has a condition all of its own. It is the boundary condition. There are different forces that operate at the boundary condition of any two substances, such as the surface tension of water. Pollen particles upon water dance and spin about in Brownian motion. The pollen particles are a waveform whose energy density is between that of water and air. The pollen effectively becomes an energy density level of its own. The action of phase unity upon it happens from the air, the water, and the boundary condition. Thus it is pulled in all directions. Expanded into three dimensions, the boundary condition allows waveforms to contain other waveforms without merging with them. In this form, they can effectively be called cavities, which are internal areas of less energy density. These cavities have a specific geometry based upon the boundary condition of the two interacting waveforms, the interior and the exterior. Such a cavity can form by a violent boundary condition between two mediums, literally stirring them up within each other, causing wells of little energy density. These are similar to the wells in acoustic levitation, where small objects are suspended in sound wells. To illustrate, generally, a particle can merge into the field of another particle only to the level of its own acquired energy density, such as a steel ball which will sink to the ocean floor and a balloon will float. However, in more complex systems, if the steel ball is inside the balloon, and the balloon is substantially large, the balloon will suspend the ball within it. Yet, if the balloon is small, then the steel ball will drag it to the bottom. However, as the system falls through the various levels of energy density, the action of the environment upon the boundary condition may be so significant that the boundary condition is broken. In other words, the ocean pressure pops the balloon and the air returns to its proper energy density level. Some readers may be wondering, if energy density propagates to the center of a system, how is it that the center of a vortex is its least dense area? And rightly so, as it initially seems that a proposed rule is violated or a contradiction is taking place. Enough has now been discussed to illustrate this effect. When all things are moving towards one point, even if they all had ideal straight paths, the instant one point deviates, all paths are skewed and become curves, however slight. For a unit to move in a straight line through other particles, it must have incredible energy to not be deflected off of its path. This energy would be an infinite requirement. Thus, the ray does not truly occur in nature. It is an archetypal path. Thus, the curve is the natural path, and all paths have some degree of curve. This degree of curve through a medium is one cause of a particle acquiring a spin due to speed differences on the two sides of the particle. Hence, just as the ray, non-spin is also an archetype. Image 43 shows a wave path in the archetypal ray. When this path curves, it immediately shortens the distance of one of its sides. Being that all electromagnetic waves propagate at the same speed, the interior side of the path now has the same energy in a shorter distance. Thus, it is more energy dense. This curving path curves every other path that it has, quote unquote, cut off to even a sharper degree, causing them to be even more energy dense. The polarized energy density of the path begins to fall through itself, attempting to equilibrate at their proper density level as they would in a sphere. Thus they begin to spiral around each other. This causes the frequency of each pair to increase on the interior side and decrease at the perimeter. noted by the red and green dots respectively. Thus, energy density again propagates to the center. However, this is still only two-dimensional. In a vortex on the surface of a medium, such as water, this collection of curving paths, increasing in density towards the center, would basically look like the disk in image 44, with the darkest spot being the most energy dense. However, this disk would also be contained in a system, the ocean, and the disk's various density levels would move towards their proper density level in that system. The red arrows denote the degree of the sinking to the sea floor. Thus, the disk form warps, bending the boundary condition and causing the medium on the other side, the sky, to get bottlenecked, consequently increasing in energy density as it descends into the vortex with increasing speed and pressure. Thus is formed the energy density gradient of the vortex, seemingly contradicting the law of energy density propagation at first glance. All energy must be of equal energy density to merge. This bottleneck is one way energy density of a medium may be raised to the significant energy level to pass the boundary condition and enter into a higher energy level. It is also a method by which a system can absorb energy from outside of the system and grow. Thus, the flow of a particle through a density gradient towards the center is synonymous with simply raising its energy. Conversely, lowering the energy density of a field or object would cause it to leave the center, such as with anti-gravity. This brings the discussion to the nature of the ejecting flux of the vortex. In its purest nature, it is a continuation of the recursive spiral model. As discussed, density will seek its proper level, and low-density cavities formed in high-density areas will eventually be ushered to their proper level of energy density, such as light from the center of the sun. As energy accumulates in the center of a system, and impure energy is broken down into purer energy, this phenomena occurs more frequently. This low-density energy formed near the center is ejected out to its proper level. In larger systems, this ejection can be quite significant, as the jets of galaxy PKS 0521-36 show on page 20. The energy spirals out in pairs as discussed above and shown in image 45. This pairing, known as Birkeland currents, has been recreated in the laboratory and seen in space, image 47. The fact that plasma travels in pairs can also be observed in the common plasma ball novelty devices, image 48. The ejection has interesting effects on the surroundings. In addition to the force of the ejecting stream, its spiraling nature can also affect surrounding bodies. The worm gear and the heliacal gear below represent the ejecting axis and a spiral surface of an ideal field system respectively. Note that a heliacal gear is a worm gear, just as the perimeter of the ideal field model is its axis expanded. The only difference is the angle of the peaks and valleys from top to bottom. For example, the heliacal gears have 18 peaks, or teeth, but their angle is so gentle that they barely make it 20 degrees around the shaft. Now the worm gear has but one peak, but of such a severe angle that it traverses over 2,000 degrees. As can be seen below, an axis gear could affect the top or the side of a system depending upon their flux angles. These angles of flux are illustrated in greater detail later. Recalling the infinite recursion of the model, any ray of flux could be said to act as an axis gear which penetrates and thus acts upon systems with the proper receiving geometry, a negative image of the waveform. Phenomena such as magnetism may result when the emitted flux of a substance is received by another substance whose receiving geometry is the negative geometry of the spiraling flux. This very effect can be seen when fastening a board with a screw. If the board is not secured, the screw will draw the board up the screw as opposed to fastening it down. This may be the mechanics of magnetic attraction. Some objects allow flux to flow through and become affected thereby. like a piece of paper on the back of a fan. Yet, other objects do not have the correct geometry, like the human hand in a magnetic field, and are completely unaffected by the passing flux. Thus, the flux will affect only those materials whose geometry will receive it. This may be the very reason for aluminum's odd reactions to magnets, as it causes magnetic braking more strongly on the north side than the south side. Possibly its waveforms are only favorable to one-handedness of the flux. Similarly, with bismuth's ability to repulse both poles of a magnet.